We're going to try to prove we'll be required to prove the quotient rule. So if you have to take a derivative of, okay, let me say you have this function h of x, which is f of x over g of x. If you got to take a derivative as it's showing here, you should take derivative of the upper function, take the below function as it is, and below function derive it, then the upper function as it is divided by lower function g squared. Okay, we'll have to prove this statement using first principle. So we know first principle that well, let me say you were taking derivative of a function f of x, that should equals to f of x plus h minus f of x all over h squared. That's what we know. So this is all that we are going to use for this proof. No extra. We're not going to use the product rule. Remember that on the previous video already you proved the product rule, so you can use product rules to prove this, and it's very quick and easy. But sometimes for exam purposes they might say do not use the product rule, unless if you have proved it, you can just say that you already have the product rule, just use it to prove here. But in this case we assume that we know nothing about product rule, just going to use first principle. Okay, this is how this should be. Okay, let's talk about our function h of x. We're trying to find or we're differentiating it, find limits as h approaches 0 of the function. So this function is made up of these two functions, obviously. So we'll, whatever this x, will put x plus h, so it's going to be f x plus h, but there's also at bottom parts x plus h for g minus functions as they are, and then like this. Then if you notice very well, I haven't done anything clever. It's just used substituted the laws of the, or should I say, I've just used the first principle. So again, limits as h approaches 0. Oh, that should be also miss something very important here. That also should all over h. This is the h that I missed. I have it now here, so everything is fine. I put it on the side. It's the same as putting in the bottom. Same as just saying this is all over h, but it should be quite dirty, so I'm gonna keep it simple like this. So it's the same thing, so hope you're convinced it's the same thing. Okay, then if you are convinced, we can move forward. Now we can say use we're going to use our legal algebra, x plus h, doing the common denominator, and you know it. I'm not going to do it for you, just going to see how I'm doing it, because this is just algebra from now on. I have nothing clever yet. And then there is going to be f of x plus h, and we're going to take that one, g of x on this side, minus f of x, and we take the other one. It's going to be g x plus h. Okay, remember outside we have that h. I can just plug it just here. Okay, so we're still saying limit as h approaches 0. This is where we do something clever. Okay, I'm just going to copy this, x plus h close g of x. Something clever, we do it here. We're going to add a term and subtract a term, of which is like, we're just going to add 0. So who cares if we add 0? No one has a problem with that. Hope you don't have a problem if I add 0. Okay, then I'm going to add 0. This is how I'm going to add 0. This is me adding 0. Okay, I add something and remove that. That is equivalent to adding 0. Okay, what was there? I still have f minus x g of x plus h. Good. So this is the thing that we have done here. I think this is the most clever part about this proof. If you can remember adding and removing this term, you are done with the proof, because whatever is remaining now is just limit laws, your algebra. So in the bottom I have gx plus h and g of x, and that below h that has always been here. Okay, so what do we do now? We notice that there is a common factor here. Okay, let me just remove this so that it doesn't confuse you. There is a common factor here and here, and there's a common factor here and here. So let's just try to find a common factor here and here, of which I see something like, I see g of x. Let's just say limit as h approaches 0. The common thing I said was g of x, and if I take out g of x here I'll be left with f of x plus h, and here I'll be left with minus f of x. That is supposed to be minus f of x, and then close that. Okay, let me look at the other side. What is common? I have f of x and I have f of x here, so I'm going to take out f of x, and if I do take out f of x here, I'll be left with g of x minus g of x plus h, close, and that is still all over g of x plus h, g of x, and then that h. Okay, so what I notice here, this is exactly how we want things to be, because this is almost how the first principles is written, but here it is more of upside down. So we're just going to try to write this in the way that we expect it to be, of which is just going to factor out -1. If I factor out -1 here, it'll be here it's going to be plus, here it's going to be negative, and here it's going to be negative. And yeah, now it is in the good way. So it is now in the same format as this one. Okay, so what can we do now? We can consider this as a fraction on its own, and consider this one as a fraction on its own. Then I think we would have tackled the problem. So we're still saying limit as h approaches 0. Okay, but now we have g of x here. I also have a g of x in the bottom, so I don't need to keep on with this g of x. Let me just, oh no, not yes, because you're not going to understand how I did that. Let me just g of x, here I'll have f of x plus h, close, here I'll have minus f of x, close, minus, I'll rewrite that in the format that you can easily recognize where we are going. So I'm going to start with g of x plus h. Don't forget to use brackets as much as I'm doing. It really makes the work understandable. It's make it wrong anyway. So then minus g of x, then I can put the fraction g of x plus h, g of x and h. I can put it on the other side again. I just did what I told you to do, that this denominator for this and this denominator for this. Okay, so it's going to be g of x plus h, g of x, and that h. And from this side I can notice the g and the g going away. Okay, so now I can write it like this again. Limit as h approaches 0. I can write it as this g x x plus h, and here I will have f of x. I'm just separating it, so I have nothing clever again. Minus f of x, should have used bracket here. That is all over left h, and minus on this side I'll have f of x, and the denominator g of x plus h, g of x, and there should be bracket here, and then and then here we'll have g, they should be this here. Okay, g of x plus h minus g of x, that should also be that should be all over h. Now I can take the limit. This is the last step of the proof. If I make h approaches 0 here, I'll just have 1 over g of x. And if I make I take limits as h approaches 0 here, on this I will have what? That will be just a derivative, a derivative, or differentiating the function of f of x. So it will be just f of x, first derivative, and then minus, if I take a limit as h approaches 0 here, I will have f of x all over, this will become 0, and I'll have gx. And again, if I try to take a limit here as h approaches 0, it will be same as taking or differentiating the function of g of x. Looking good now. So we no longer have limits because we have taken the limits as h approaches 0, and now we are here. From here, what can we do now? This is a binomial, right? This is a binomial. We try to make it of the same denominator by multiplying g of x. Okay, if I multiply by g of x here, I'll have g squared, right? So let me just put g squared here, g of x squared. Now I can take these because they are now of same denominator. I can just say g of x squared. And what do we have here? Here I'll have g of x, and I'll have this, minus here I'll have f of x, here I'll have g of x. And I think we have proved the quotient rule that says that it's just taking this as it is, derive this one, minus take this as it is, derive this one, all over g squared. We just proved the first the quotient rule, of which if you go back slightly, scroll back in the video, that what we were required to prove just here. So please subscribe, comment if you find the video informative, and there's also another proof for product rule. If you didn't watch it, just find it, I'll put a link just up here.